As far as lessons learned on ARES 1X, to me, one of the big ones is you want to take a little more time up front to prepare for what you're about to go do. Now, in 1X, when we started, we hit the ground running, and it was just, all the time, go, 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 charge, charge. My take on it is if we'd spent an extra month or two up front, when we finally decided, when we had our big lean event that came up with our new org structure, if we'd taken just a little more time, a month or two up front, to talk about the configuration management, how we're going to do verification, things that as we went down the road became contentious and actually cost us time, in my opinion, down the road. If we'd taken a little more time up front, where we got everybody together, and this would not have been easy, and it wasn't easy the way we did it, but if you get them together up front, the right people, and you've got to have them all face to face. I'm a big fan of face to face. You can read body language, and when you sequester people together, you kind of throw them in the lifeboat together and say, okay, now you got to swim or stay together and somehow stay alive, as opposed to everybody just teleconning in. And what you see with that sort of thing is people, they're checking their email because they can do other things. They're not, wedded to what they're doing. They can try to multitask, which is something we try to do too much of sometimes. So we don't stay focused enough, long enough, to really do the deep, meaningful thinking you have to do to accomplish some of these things. So you get everybody together in one place for 2 weeks, a month, whatever it takes. But you think about the specific things you have to go do, as I indicated before, configuration management, it was a verification, those things. You get them together and you talk those things through. And you don't just talk about them in very amorphous terms. You want to get together and talk about very specific examples. You show them, here's the sheet of paper you're going to fill out. Now, here are all the blocks you're going to have to fill out. Here's the things that have to happen. And you talk through specific examples. Because when you talk at a very high level, you can reach some very high level agreements. Yeah, I understand what you mean. And on 1X, as we found out time after time after time, we thought we had agreements, and people were talking two completely different languages. It's just the culture of the centers and the way we were brought up. So if you get them together, you force them to run through specific examples, you find out, hey, I didn't realize what you meant by a design certification review. I thought it was this, and it would come at this time. No, here are the blocks that have to be filled out, the things that I have to do to satisfy myself so I can sign the certificate of flight readiness. Only when you do that, and you take, like I'm saying, I think a little more time up front, you'll pave the way and save yourself a lot of heartache down at the end. Because especially when you get to the end, and there's nobody that's going to disagree with me about this, at the end, you are just 80-hour weeks are the minimum. And you're really trying to get there because the schedule, you got to get there. And we had a very motivated team, great people, no exceptions to that rule, all of them. And they were working as hard as they could. But you're getting dog tired at the end. And you're motivated by the adrenaline of what you're about to go do. But if we had solved some of that stuff up front, it would have saved a little bit of that energy for other things, and maybe life would have been just a little bit easier at the very end.
There's a key lesson learned that we experienced in going from formulating the project as, hey, here's what we think we can do in response to that question that was asked by senior management, to where we wound up being by the time we launched, and that was what was originally cast as a lean and mean, a quick and dirty kind of Class D, Class C flight test project wound up being essentially graded by almost human spaceflight standards and specifications as we went through our final acceptance and launch readiness review process during the launch campaign. Early on, when we were doing the formulation studies in the winter and spring of 2006, starting really in December of 2005 to the time we got the provisional authority to proceed and the first drop of money in May of 2006, we had scoped out what we thought it would take to do this in-house design-build job at Glenn Research Center. And that initial number was just too high, too big, and I'm talking cost now, for the powers that be that were trying to sell the project. And so we were put under pressure during that spring of '06 to scale back our estimate, do whatever it took to take content out or to skinny it down, and to come up with a lean and mean cost estimate. And we came in around, I don't know, I think it was $36 million to design and build and deliver and launch the USS over what was going to be the 3.5 years initially, and that's what we went into the ATP with in May of '06. Well, our cost grew over 40% over the life cycle, and we wound up coming in at mid-50s in terms of millions of dollars over the 4 years. And that when we actually went in and we parsed all of the elements of the cost growth, because we worked with very detailed bases of estimates for our team. We could do that really well since it was an in-house project. And what we found was that 2/3 of that cost growth was driven externally by the increase in scope and the creep in requirements compared to what we had been driven to as an initial, final line in the sand of a lean and mean approach to building the upper stage simulator. And so as we saw requirements creep, we saw it really start initially in the September of 2006 timeframe as the what was called the VIO, the Vehicle Integration Office at Langley, got stood up over the course of the summer. This is after we got the authority to proceed, mind you. And as those folks at Langley got engaged and started writing requirements, starting with the overall test plan and then going into an SRD, a system requirements document, all of a sudden there was a host of specs and standards and requirements that were put in writing that we had not scoped or costed into the USS project that we proposed at authority to proceed. And it grew and it crept from there. So this is really a classic tale. ARES 1X is certainly not the first project that has experienced requirements creep and scope creep, and was not able to bring enough discipline to the cost and schedule impact assessment and change control process as those requirements crept early on. There's no silver bullet for this. Configuration management and guarding against scope creep is hard. It's not easy. It takes a lot of very disciplined and focused and attentive work and systems and processes in place to very carefully define your configuration and then to hold it.
Another lesson I would offer that pertains to integration is an area where integration takes a lot of time and really needs to be thought out carefully, and that's integrating sensors onto the vehicle, specifically the developmental flight instrumentation, or we call it DFI. This is the instrumentation that allows you to gather information about the environments that the vehicle saw, but is not in any way used to control the vehicle. So it provides data back, but does not have anything to do with flight control or commanding. In our case, for 1X, we had over 700 sensors and of different types. And I would just offer to the next project that you really have to think through carefully how those sensors are going to be tested when they're integrated onto the vehicle, where those sensors are going to be located. Do you have the procedures figured out to do that testing? Do you have all the ground equipment? Do you have breakout boxes and other test equipment ready to go for that activity? Do you have test cables ready to go? On 1X, we kind of learned as we went along to some extent on the DFI, and we certainly learned that interfacing sensors to the vehicle is a complex process when you have to deal with conductivity and vibration and other issues and not affect the measurement in an adverse way. We were fortunate in that we were very successful in the DFI system, but it took more time to develop and integrate than was anticipated. And so I just offer that as a lessons learned to the next project manager, that pay close attention to how much time it's going to take for sensor development and installation.
One of the areas that I think at the beginning we had to learn about, and we had to learn the differences between the various different centers, was there's really two portions, the SE&I, that's system engineering and integration. There's system engineering and there's system integration. Although they're distinctly different things or entities that you got to deal with, they are highly integrated. That's why they're all usually in one organization. In the case of ARES 1X, you always have the S&E, system engineering issues, that will start from the beginning of design all the way really to launch day. And yes, we were working those all the way to the beginning of launch day. It's the system integration stuff that we started out one way, and then the ARES 1X team changed the way they were going to go do business. And I think the mission management team can talk more about how they did all that. But in the end, the SI part of the equation then became a little bit weaker. And so by the time we were getting closer to bringing hardware to Florida, that's when the SI part really has got to happen, because each individual vendor, each of the individual contractors can work in their own systems. It's when you bring those together to say, how does this part going to fit with this part? How is this process for resolving a problem going to fit with this process for resolving a problem? And they're all in the same high bay in the VAB. They're all in the same firing room. They're all in the same location, literally. And so those, we thought we were going to figure out ways to work that before the hardware got here, and we put some things down. But there probably was not enough energy put in the overall project in order to go make that, pound that flat before the hardware got here. And you always know you're going to have trips and falls once you get the hardware here, and you got this process doesn't line up with that process. But you think that's 5 or 10%. In this first test flight, and I'm not saying there's anything wrong in the overall thing, but in the first test flight, you got to expect 30 or 40% breakage in processes, and in the fact that this part doesn't fit with this part, and this process doesn't fit with that process, and the way you do troubleshooting is different than the way this other guy does troubleshooting. And so a first test flight like we had this time, the lesson learned would be expect 30-40% breakage in those SI processes, and not 5 or 10% like you might think of. Because I think we were thinking it'd be 5 or 10%. In the end, I think it was 30 or 40% breakage in that.
Yeah, one lessons learned, we used some lean events to walk through our schedules and find out what areas can be improved. And there was kind of a mixed bag that came out of it. Some of the suggestions were fairly readily implementable. Others required a lot of work. However, we really didn't have some person who was tagged to really go look at each of those enablers to ensure that if they could work, that they were workable and that we could get the schedule savings that we had pulled out in the lean event. So what we really found out is the lean events are very good at identifying areas of potential improvements to the schedules, but it really takes almost a full-time body to take those enablers and put them into action to get them worked, to see which ones are workable, see which ones aren't, and see what real savings you have in your schedule.
We started off with a set of objectives. Have your objectives. Make sure that they are. You want to make sure that they're tied to whatever you're doing the test for. In our case, it was for ARES 1 knowledge. Make sure that it's timed right. We were flying our test prior to the critical design review for the ARES 1, and we made the objectives push us far enough that we were going to learn something, but not so far that we could not, that we were adding a lot of risk in terms of meeting the date and the budget that we had allocated to us. So the first lessons learned is come up with a good set of objectives, a reasonable set. We had 5 primary objectives, and they held up basically from the time we baselined those all the way through to the end of the mission. And incidentally, we met them. So that's one. Number 2 is that if you're going to do a flight test program, understand that up front what the level of risk that you're willing to accept in the mission is. For example, on a human or a human rated mission, you have to have very, very small probabilities of failures or catastrophic failures. You have to have redundancies and so on. With a flight test, you may be willing to trade some of those off for the expediency of getting that job done, but you have to understand where that level is. For example, are you accepting a 90% chance of missing an objective? Would that be acceptable? Is 80%? Is there a way to actually calculate? That's another question. But nevertheless, you have to understand that risk level. So I think that's a very important thing. And it was one that we actually wrestled with quite a bit because our agency was very used to, at least the group we were dealing with flying human-rated systems. And so there was a sort of a cultural view based on that experience. And we had to go in and negotiate that, which we did eventually, but it took a little longer than I think that it was necessary to do. So the next group that does this, do that early. Try to get an agreement written down, signed. It'll enable you to move on a little bit more rapidly, and it'll shorten later disagreements when you go downstream and you've got test issues or anomalies, and the question is, what do you do with these things? If you have a well-understood philosophy that has been translated into a reasonable direction, it's much easier to handle those problems.